Let's assume you have a continent, and the mountains that are here today in the world didn't exist. Didn't exist. So it looked different, and you had huge inland seas, and you had an ocean basin. And then something happened, and the whole continent was pushed under the sea. That means the sea would rush onto the land, and all the sediments in the sea would go onto the land. Then you would have the sediments of the ocean mixed with freshwater sediments here on the land. And then you do the reverse. You lift up the continents again, folding takes place, the mountain ranges form, and the new ocean basin forms. And the sediment that was in the ocean is now on top of the land, and you can see it in the mountain ranges and all over the place. And that's what it looks like. The sediment is on the land instead of in the ocean. Where should it be if the oceans have been around for hundreds of millions of years? Where should the sediment be? The bottom of the ocean. It's not there. It's on land. Well, that's very strange. Let's have a look at these layers. Here are two layers in the Grand Canyon. The one is called Coconino Sandstone. The other one is called the Hermit Shale. You can tell them nicely apart. They've got two different colors. And you can see some interesting structures. Boom, there's one. It's called a flame. Here's the one layer. There's the other layer. And here there's obvious mixing. Can you see that this one over here is as if it were whipped into the top layer? Can you see that? So something came rolling along and whipped up some of the bottom into the top and mixed them. Now, if this layer over here at the bottom were millions of years older than that layer, would that have happened, yes or no? Never. This is a geological nightmare, because this cannot be explained other than by catastrophism in water. Or could I depress a top layer into a bottom one, squelching it, not breaking it, going if the bottom layer weren't soft? Impossible. Could I fold mountain ranges like this or like this? Could I just take the layers and go like a bunch of layers of dough in a whatever donutty thing? Could I just go do that? No, unless the layers were soft. Now remember, science says each layer was the surface of the earth. Each layer constitutes millions of years turned into rock. How am I going to bend this without shattering it into millions of pieces? Impossible, unless the layers were soft. So how does science solve this problem? I say, well, what must have happened is they were rock, but then there came a time of continental depression, and it went down into the heat of the earth, and there it became molten. Then it was lifted up and folded. Hello, here's a problem. Then there should be evidence of this heat upon the rock. But most of these rocks are sediments, no evidence of any heat, no volcanism, just water, mud, and fossils. No heat. And they're all folded like that. So it must have been soft. Here's another interesting one. Here's a finger sticking through another layer of mud. Obviously, this finger is hard, this layer is soft, so this erodes away, and there stands this finger. Ding! What's it doing there? Where's it come from? So if you look at the layers, this is in Kodachrome Basin, also here in the United States, different layers. There they are. And the bottom one over here somehow had columns shoot up through the other layers, and then solidify there. So this one over here shot up through this one, through that one, into that one, and there it sits. And that one shot up from that one through the others, and there it sits. Now erosion takes place, washes it away, and there stands a finger. Bing. Now this is very intriguing. Imagine you have two layers of glass, tabletop glass, you know? Imagine you have two layers. And now you have a tube of toothpaste, and you go to the glass, and you take your tube of toothpaste under the glass, and you go, squeeze! What will happen to your toothpaste? It'll go, peek. And if you look at the top, you'll see one big flat patch, right? Because the toothpaste cannot go through the glass, it's solid. Now, the same with these rock sheets. If I'm going to say the bottom layer is getting soft, and I go, squeeze and go, phew. How can it go through the other layers if they are solid rock? What should the mud do? It should go, but it didn't. It went toom, 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 through all of them. What does that tell you? It tells you that when this happened, they were all soft. So they were laid down, and there was an earthquake, put pressure on the layers, and it went chop, 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 chop. And they shot columns through, and then they got stuck, and then they dried, and they formed this. And that's how you get that. Only if they were all soft. So there they are, standing there as though they should have been there. Of the Fish River Canyon, beautiful erosion features, ripple marks, again, water features everywhere. And there is this canyon. Look at it. Nice V-shaped canyon going round the corner. It's not as impressive as the Grand Canyon, but you know, not everybody can keep up with you guys. And this is the Orange River Canyon. Here comes the river, makes this huge waterfall, and then flows in this beautiful canyon. Can you see the canyon is V-shaped? Can you see that? V-shaped canyon. So now we've seen the Fish River Canyon is a V-shaped canyon. This canyon is a V-shaped canyon. The other canyons in the world, V-shaped canyons. The Colorado River, here you can see the goosenecks. Notice that it is V-shaped again. There you can see it beautifully V-shaped. Now, a scientist published in the journal Science an article where he said, we have a problem. Because if it is V-shaped, then it had to be rapid. It could not have been slow, because slow undercuts and deposits. So all of these canyons must have occurred instantaneously, rapidly. So that was rapid, that was slow. So what washed it out? What happened? This is another canyon that formed instantly, Canup Creek, and you can see it's also V-shaped. This beautiful washed out area. Notice this massive washout. There's a human being as a scale. It's fascinating to see what happened over here. Everything in between is just gone, washed away. Everything in between. Erosion has eradicated it, leaving these magnificent monuments to some water activity. This is Monument Valley. Notice these mounds that stand in this valley. Now, once upon a time, these were all flat sheets, one on top of the other, and what has washed everything in between away? What does science say? Millions of years of erosion. But in actual fact, when you look at them, is it possible that it could have been rapid erosion rather than millions of years? There are the monuments, there they are. Everything in between is gone, and these stubbornly remain behind. Look at those two, standing side by side, like two cooling towers at some factory. Amazing. There they stand. Everything else in between is gone. Millions of years of erosion has taken it away. Those are the Navajo twins, and everything else in between is gone. I'm going to take you to an area in Africa. And this is in Basotho land. And here is an interesting feature. This happened in one rainstorm. Notice that the rainwater came and washed away all the material, leaving a mound there, a mound there, a mound there, another one there, another one there, another one there, a couple over there, and a range over here. And that is what happened in one rainstorm. Now, why are these still there and everything else is gone? Imagine this. The water's coming along, washing away the soil. It's busy digging these channels, taking away the mud, and then all of a sudden the rain stops, and what happens? The water's gone. And before everything could be washed away, it dries out and leaves these mounds. Now, isn't that exactly what Monument Valley looks like? Yes or no? It's exactly what it looks like on a small scale. There's a little canyon that formed in just a rainstorm. There's another one. Notice the V shape, exactly the same.